Alright, so we're going to quickly check the answers to the homework that you guys did last night. What I hope is that this went well. I hope this was just good practice opportunity to get you ready for the sticker challenge that's going to start in just a few minutes. Oh, yeah. That's right. Alright. Right, so to evaluate a definite integral, you find the antiderivative. Antiderivative here, 1/3 x cubed plus 2x squared plus 3x. I'm looking for the vertical bar. We're evaluating from 0 to 3. You evaluate at 3 minus you evaluate at 0. Big mistake that people are going to start making is the stuff that comes after the subtraction sign. They're going to forget about the parentheses. If all goes well, you have 36. Okay? Number 2, your antiderivative, natural log of the absolute value of t. T, the homework assignment you guys turned in yesterday, I was looking, and oh my gosh, so many people forgetting the absolute value bars when it comes to the natural log. If you forget them, it's not the right antiderivative. Other big mistake people have been making is if I give you an integram that's in terms of t, you're doing things in terms of x, no bueno. Evaluate, simplify. Number 3, antiderivative sine of x, negative cosine of x. Evaluate, simplify. Number 4, antiderivative 3e to the x minus e to the negative x. Evaluate, simplify. So that what you couldn't see is 3e cubed minus e to the negative 2 minus 2. Okay? Number 5, I'm curious, what were all like the smart folks doing last night when they came to this problem? How would you ever evaluate, find an antiderivative of something like x times the cubed root of x? Polymon, what would you do?
Well, you turn the cubed root of x into x of 1/2 and then just...
You turn it into what?
X of 1/2.
The cubed root of x?
Oh, no, I mean the square root.
No, the cubed root of x?
It's a cubed root.
So you make this...
Oh, yeah.
Okay, so instead of x times cubed root of x, you make an x times x to the 1/3, and then you're going to use your algebra skills to say x times x to the 1/3 is x to the 4/3. Add 1 to the power, divide by the new power. Your antiderivative is 3/7 x to the 7/3. Evaluate at 8, evaluate at 0, subtract. Now here's the thing. I just want to get this loud and clear. In the middle of a test, I am not likely going to ask you to simplify something like 3/7 times 8 to the 7/3 minus 3/7. It is not worth your time. Okay? But on the homework, I'm going to push you guys to simplify as much as you can on the homework. So I'd say the right final answer is 384 over 7. In terms of this first column, did anybody go 5 for 5? 4 out of 5. I can do 4 out of 5.
I did 3 for 3.
Okay, you went 3. I did 3. I got 3 right. That's pretty good for me. All right, number 6. Now you need to start getting... Oh, yeah. Okay, so now number 6, now you need to get a little more clever because right now we don't have any rules for division, so it's always going to be algebra trickery. My favorite way to handle division is I say make it 1 over y plus y squared over y, simplify. Antiderivative natural log of y plus 1/2 y squared, evaluate, simplify, natural log of 2 plus 3/2. Number 7, antiderivative sine 2t, negative 1/2 cosine 2t, plus 1/4 sine 4t, evaluate from negative pi over 4 to pi over 4, simplify, oh how kind, all these zeros, and you get 0 for the final answer. Okay. Number 8, 2 over r cubed. This is another one where your algebra skills will be helpful. Make it 2r to the negative 3rd. Add 1 to the power, divide by the new power. You get negative r to the negative 2. Evaluate, simplify. Final answer should be negative 8 over 9. Number 9, antiderivative of secant squared theta. Tan theta. Just need to know it on sight. Evaluate from 0 to pi over 6. If it's free response and you have no idea what tangent of pi over 6 is, leave it. But on the homework, I do want you to get practice with simplifying things. Like, so find sine of pi over 6, cosine of pi over 6, divide and simplify. Antiderivative secant of x, tangent of x. is secant of x, evaluate, simplify, 0. I'm not going to pick this one up for a grade.
Why not?
Because I said so. I have so many grades in my grade book for you all, like more than all your other teachers combined.
It's true.
That is true.
I mean, let's be real, okay? Anyway, I'm not planning to pick this one up for a grade. So I wanted this to be a learning experience. We just played around with definite integrals yesterday. Okay, the one that you're gonna do tonight, this weekend, Monday morning on the way to class, is gonna get picked up for a grade, so be ready. All right, here comes the sticker challenge. If you could put everything away, please. You have 5 minutes. One, two, three. No, that's Celeste.
Mine's also over there.
Yours also over there. Excellent. Good to know. There you go.
Yeah.
There you go. Thank you. Don't play them that way. All right, you have a grand total of 5 minutes. I won't be surprised if some of you are able to finish this in less than that. No talking to anybody. Enjoy the ride. I want to be a proud papa.
You also have the test corrections and reflection form.
Three more minutes. Don't forget Charlie. Shoot, less.
Bless you.
Alrighty, friends, here we go. Alright, number 1. Who's got it for me? Integral of x to the n. David.
1 over n plus 1.
1 over n plus 1.
N to the power of, no, yeah, x to the power of n plus 1 plus e.
Okay, love it. Okay. Next one, number 2, integral sine theta d theta. Aaron, what you got?
Negative cosine theta plus c.
Negative cosine theta plus c. Nice. Integral of cosine k times x, where k is a constant. Andrew, what do you got?
1 over k
1 over k.
times e.
Times e?
Oh, I mean, aside
Sine. Yeah.
k of x
kx
plus c.
plus c. Steven, integral of k e to the kx dx.
It is e to the power of kx.
It is e to the power of kx plus c. I agree. Yeah. Sure.
E to the negative x.
E to the negative
Plus
x
c.
plus c. I lay antiderivative 1 over x dx.
Natural log of absolute value of x plus c.
Natural log of the absolute value of x plus c. Without the absolute, my candies aren't good enough for you. Fine. Without the absolute value bars, it's wrong. Celeste, antiderivative 1 over 2 square roots of x dx.
Square root of x plus c.
Square root of x plus c. And Carmen, antiderivative secant theta, tangent theta, d theta. Not sure.
1 over cos theta plus
1 over what?
cos theta.
No, secant.
Okay, so what the unusual young man in the back said was 1 over cosine theta plus c. What the aggressive young woman up front said is secant theta plus c.
Same thing.
And these are the same thing. How on earth you've got 1 over cosine theta, I am never going to know. We're just going to thank the Khan Academy and Googling. I'm not even interested. Okay. The antiderivative of secant tangent is secant because we know the derivative of secant is secant times tangent. How many of you guys got all 8? How many got 7 out of 8? It's a Friday. I'm feeling generous. If you get 7 out of 8 or 8 out of 8, you earn the sticker.
No, you get you don't get a sticker.
Okay. All right. Now, wait, not yet. Hold on. Next one. Antiderivative of 5t to the 5th is 5/6 t to the 6th minus 1/5 t to the 5th plus 1/6 t cubed minus 3/2 t squared plus the square root of 2 times
That's
the square root of 2 times.
X.
Stop saying x.
Oh,
T.
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 oh, I put x2.
I know. I know.
the only x there.
And so, I would have hoped that after all these t's, you're like t x. Antiderivative 4 cosine theta. 4 sine theta. Plus 1/5 cosine 5 theta plus c. Antiderivative e to the 4t, 1/4 e to the 4t, minus 1/2 e to the negative 2t, plus c. And this guy here, we just talked about it in the homework. Right, you're going to have to do a little bit of work first and make this x squared times x to the 1/2 dx. Which becomes x to the 5/2. Add 1 to the power, divide by the new power. Is everybody okay? I'm not actually bothering to write out 5/2 plus 1 anymore. I'm assuming our fraction skills are sufficient. I'm also not going to write 1 divided by 7/2. I'm just going to multiply by 2 over 7. But the rule is add 1 to the power, divide by the new power. Everybody's okay?
Yes.
How many guys got all 4 right, with the exception of you decided to use an x over here?
Yeah.
Okay. If you get 7 out of 8 right or better on the first one, you get a sticker. The stickers are on my desk. If you get all 4 right on the second one, you get a sticker there as well. It goes in the first 2 columns.
I'm really glad you can count.
Instead of I was thinking we were gonna do a separate.
I was wondering what you were doing. I was like, oh my god, he doesn't know how to do any of those.
They're easy.
I know they were.
Look. Perfect. I'm really glad Mr. D can count.
Giselle, you can get a sticker if I can
Well, you
just
get 2.
turn around and you can
We get 2 in 1.
You get a sticker in column 1 if you got 7 out of 8 or better. And a sticker in column 2
No, you're
if you got
hitting me.
all 4 right here. So column 1 you get a sticker.
Yeah.
Okay, my friend over here. There's going to be an opportunity to do this again next week. Okay? And I have faith in you. You always figure this stuff out. It just takes a little bit longer. That's fine. Okay. Study that folder. These. You get a pop, pop, pop. Alright. Is somebody tickling column back there?
No, the opposite.
Alright. No, don't give Myra a sticker. We have no idea what she's capable of. She may not have gotten those right. Alright, friends.
Oh yeah, David doesn't get the stickers. Myra gets the
Oh, Myra gets stickers today because David's playing the role of Myra.
stickers. You messed up.
Alright, and for David, Lewis, and Polymon, just your last reminder about the AP student panel happening in room 36.
I got the.
Can one of the young women in the class make sure that if you see them during lunch, you're like, why are you here? You're supposed to be in room 36.
No, actually, remember. Who?
David, Lewis, and Polymon.
Okay, I see Dave.
Alright, my friends, here's the plan. Between now and 9:20, you're going to go challenge by choice. There are, this is on the front page, page 15. There are 5 really challenging questions for where we are right now. Between now and 9:20, I'm going to invite you to do any of these that you want to, either on your own, go over to the side, or you're going to stay up front with me and we're just going to work through a couple of these so that you can get some more practice. We're just focusing on definite integrals and evaluation and some algebraic trickery. The last 20 minutes or so, we're going to pull everything together and do some application problems. So those of you that are going to go, like, you're just going to go and you're going to work because you know that things are good, go to that side of the room. Friends that are over here, you're going to stay with me. Now would be the time to move.
I didn't hear you say.
No, that's not possible because I've said it twice now. Okay, so are the 6 of you staying with me? And the 4 of you, are you technically on this side of the room? All right, with the folks around you, I want you to have a strategy conversation. What would you do with problem number 2? You're staying with me, we're going to do it my way. I'm looking for strong notation here.
Wait, I got it.
Friends over here on the side of the room, what's the strategy? What are we gonna do? What are we trying?
We moved the T up.
Okay, great. We know we have no integration formulas yet for division. They are coming, but they're a long time away, so we need algebra cleverness here. Polymon said bring the square root of t up, so it's like t plus 1 times t to the negative a half. Did anybody else do it that way? I saw other people who said, like, let me make this into like 2 fractions.
Oh, okay.
Okay. Either way, what I'm looking for is I want to see strong notation. I want to see this is the work you're doing in the integrand. You still have a definite integral. And now once you've made this first move, maybe it's not so bad. T over the square root of t. Oh, what can I do there? I can make that, what is that, t to the 1/2? Right, because this is really t to the 1. This is t to the 1/2. You would divide and subtract exponents. 1 over the square root of t, another way to write that? Is t to the negative 1/2. I'm integrating with respect to t. I'm going to be ruthless on the notation. Aaron, you look like you have a question.
Oh,
You okay?
I thought I did.
Right, I haven't done any calculus yet. This is just algebra. But now, hopefully we're at the point where we know how to find the antiderivative of t to the half. What's t to the half going to be? I'm starting with t to the 1/2. This has to be a power rule problem. Add 1 to the power,
It's gonna be
divide by the power.
2 over 3.
Okay, so add 1 to the power, divide by the new power. So 2/3 t to the 3/2. Power rule over here. Add 1 to the power, divide by the new power. T to the 1/2 times 2. And we evaluate from 1 to 16. Celeste, are you okay with that?
Yeah, got it.
Right? Add 1 to the power, negative 1/2 plus 1 is going to be 1/2. Divide by that new power. Okay, now which one do we plug in first?
16.
The 16 gets plugged in first, so it's going to be 2/3, 16 to the 3/2 plus 2 times 16 to the 1/2. I'm going to keep saying this again and again. You need parentheses. You need parentheses so that you don't mess this up. It's the antiderivative evaluated at 16 minus the antiderivative evaluated at 1. 2 times 1 to the 1/2, depending on what part of the test we're on. Simplify, don't simplify. For right now, is it be okay if we don't simplify so we can focus on just more integration stuff? Okay, good.
Thank you.
All right, check in on number 3. We'll talk in a minute. Okay, good. And we're double checking answers
Oh, no, no.
in the middle of a test. We cannot do that. I don't actually know how to integrate, but I think I know.
Oh, God.
What did you?
I don't know.
What did you find?
I would start that.
Intellectual muscle at the table here.
Thank you.
So what's the plan here? What are we doing? Okay, so distributing, my first question is that legal? And is that better? Does it make the problem better? I would agree. It does make the, number one, it's legal to distribute, right? It's just a legal algebra thing. What's going to make it better is you avoid the multiplication part. Because we don't have any rules for multiplication. So integral 0 to 2, I have got to see that integral sign. If I distribute e to the 3x through, e to the 3x times e to the 3x, e to the 6x minus e to the 3x times e to the negative 3x. What is that?
That's
Yeah, what is that?
are you,
If I distribute e to the 3x through, e to the 3x times e to the 3x, e to the 6x, e to the 3x times e to the negative 3x is e to the 0, which is 1, right? Okay, dx. Great. Haven't done the calculus, just did some algebra. Aaron, what's your thought?
I was gonna say
The what?
whatever it's called.
The antiderivative?
Yes.
Okay.
Put 1/6 to the e Oh, 1/6 times e to the 6x.
1/6 times e to the 6x minus x. Good. And we evaluate from 0 to 2. Typically, on a quiz or on a test, I'm going to say, okay, you found the antiderivative? Point. Next move. Plug it in. 1/6 e to the 12th minus 2 minus, big parentheses here, 1/6 e to the 0 minus 0. And there's at least one bit of simplification that we should consider doing.
0.
Where?
The second parentheses
Equals 0?
yeah, no, it doesn't. It equals 1/6.
E to the 0 is going to be 1.
I forgot that.
1/6. So you're going to have 1/6 e to the 12th power minus 2 minus a 6th. You can make it 1/6 e to the 12th minus 13 over 6 if you get a common denominator. Why? Just because, just think about the ways I can mess with your head on the multiple choice. I'm going to hide answers from you. Another way I might choose to hide the answer is to call it e to the 12th minus 13, the whole thing divided by 6.
That makes sense.
Right? They're both over 6. So just write it as one fraction.
I thought it was in simplified.
You thought what, David?
I thought it was in simplified, okay.
Okay, I didn't want to worry about simplifying over here.
Alright.
We're good?
Yes.
Alright. See what you can do in number 4. We'll talk about it. Okay.
Yeah, that equals sine squared. Yeah, sine squared theta on whole squared theta. Is sine squared theta or cosine squared theta?
So it'll be cosine squared
Tangent squared theta.
Are you doing this? I'm gonna write it like this.
Oh,
Yeah. It's easier than this.
Yeah, this would be.
Why did I learn this in pre-calc? Oh, I don't know.
Wait, what?
I couldn't learn this in pre-calc for some reason.
You did.
No, I couldn't memorize it.
Oh,
and
okay.
And I somehow know it now.
You can thank me later.
Minus there.
Yeah, it's tangent
Minus theta.
Oh, you mean tangent?
Tangent of theta minus theta.
So there seem to be two different approaches happening here. Group number 1, they're saying, okay, well, I recognize 1 minus cosine squared theta is sine squared theta. And then down here we have cosine squared theta. How many guys are going this way? You replace 1 minus cosine squared theta with sine squared theta. Sine squared theta over cosine squared theta we know is
Tangent squared.
tangent squared of theta. And going from here to here is good and legal. Going from here to here is good and legal. And the antiderivative of tangent squared theta is not one that anybody in the room knows, myself included. So although this is good and legal and right, you hit the wall. So I need another strategy, another thought. Aaron,
We separated the two.
you separated the two. Tell me more about
We
this.
did 1 over cos squared theta minus cos squared theta over cos squared theta.
So 1 over cos squared theta minus cosine squared theta over cosine squared theta d theta. Okay, legal. And is this better?
For us,
Why?
because we know 1 over cos squared theta.
You know 1 over cosine squared theta is really the same as, wait, it's what? 1 over cosine squared is secant squared. So if that's secant squared theta minus cosine squared over cosine squared is 1, antiderivative of secant squared theta?
Tangent.
This one you know. You don't know the antiderivative of tangent squared theta, but you do know the antiderivative of secant squared theta is tangent theta minus antiderivative of 1.
Theta.
Thank you.
He's got T. Say theta. It's T this time. No.
All right, plug it in. Tangent of pi over 4 minus pi over 4 minus tangent of 0 minus 0. Tangent of pi over 4 is one that you guys are responsible for knowing and knowing well.
1.
1. Oh. So 1 minus pi over 4
Oh, good job.
minus tangent of 0
No, you're not. You're very
is 0. So if everything comes out nicely, 1 minus pi over 4. Okay. Everybody feeling pretty good? All right, I'm really interested to see what your strategy is with this last one. You don't bring the plan here like that.
Sorry.
That's what I'm here. Number 5. Steven, if I'm over here, can they everybody see me?
Yes.
Okay.
Oh, it will have to be.
You were saying that
No.
Yes.
No.
If you're integrating a piecewise function, and I think most of you guys have figured it out, I just want to make sure that folks watching at home, if I'm going to integrate a piecewise function, well, part of what I'm going to have to do is I'm going to have to actually break this integral into 2 different integrals using my piecewise function. So the first piece, I'm going to integrate from 0 to pi, and for now I'm just going to call it g of x dx. Plus I'm going to integrate from pi to 2 pi. I'm still going to call it g of x dx, and that's just a property of definite integrals from last unit. Now I know, well, what do we got here? We're integrating from 0 to pi cosine of x dx, plus we're integrating from pi to 2 pi. What is this? Cosine of x minus sine of 2x dx. How many guys honestly have this as your setup? Nice. So, Lewis, tell me what you did with this first integral.
I sine x
Okay, antiderivative of cosine of x is sine of x
from 0 to pi.
from 0 to pi, plus, Aaron, tell me about this last one.
It would be sine of x
Sine of x
minus 1/2 cos of x 2x.
minus 1/2 cosine of 2x from pi to 2 pi.
Yes.
I don't know that I'm 100% in
Plus.
agreement.
Oh, plus, right.
Right, it should be plus because the antiderivative of sine is negative cosine, but that means the antiderivative of negative sine is positive cosine. And I hear you keep saying c.
Yes.
Why c?
Well, you need it for each part of the g of x, I believe.
Oh, okay. So I hear what you're saying. You're saying like all this, like plus a little c over here. But what happens, you're going to evaluate this integrand, or this antiderivative, at 2 pi. Then you're going to evaluate at pi, and then you're going to subtract, and the c's would cancel out.
Yeah, he told us that this is always end up canceling out anyways.
Right, but I think Steven's point though was, but wait a second, it's like a different c over here than what you would have over here. But with this antiderivative, when you evaluate, it cancels. This antiderivative over here, you evaluate, it cancels. I think we're good? Everybody's... All right, perfect. We're not going to go any further than that. We've, yay! Avoid that! Because what I want to do is introduce you to the next place that we're
Oh,
gonna
let's go back.
No.
I think I want it back.
Alright.
Yeah, we need more practice.
Rewind.
No, you don't need more practice.
Are you sure?
What you need is it's time for a push. So first of all, I'm going to ask you to regroup yourselves, please. Whoever you've just been sitting with, it's time to break out, make some new friends.
Yeah.
Hi, my name's Aaron.
Hi, my name's
I didn't say your name just now.
Time to move. The group of 4, get to split up. Group of 3, split up. Group of 3, get to split up.
Here, I'll go to you.
I'm going to leave me. You know what I mean? Like,
Watch yourself.
And if I turn around, it's Steven and Andrew and Carmen and who else is back there? Lewis are all still sitting together.
No, they're not.
Okay, good. Lewis moved over. And the ladies came his way.
Hey.
Alright, so
I moved.
okay. Oh yeah, I'll be staying over here. Alright.
Oh.
This weekend's homework has 2 parts. In the problem set packet, it's assignment number 91, which is just integration practice. Definite integrals, definite integrals, definite integrals. But I also need to get you ready for this next leg that we're going to take on, which is application problems that involve the definite integrals. Calculus is all about application problems. It's all about what are some of the applications we've seen of the definite integral.
Are you asking us?
Yeah, oh, there was in my mind there was a question mark at the end of that. When we deal with rate functions, we often integrate. We go from a how fast, you integrate to a how much. Other applications,
velocity.
velocity. If I find the definite integral of a velocity function, we get, uh-oh. The antiderivative of velocity is displacement. The antiderivative of speed
I mean, total displacement.
is not position.
It's total displacement.
It's total distance traveled.
Yeah.
If you're going to talk about position, you need the fundamental theorem of calculus. We've also looked at average value of a function. We've done a lot of different application problems, but in the last unit, everything was going to be done in terms of calculator active stuff. No more calculators. So, Carmen, you okay? You look so sad. You're like, I don't want to do that. All right, so all 4 of these problems, no surprise, all 4 of these problems are going to be definite integral questions, but what I'm really interested in you're having some conversations about first is why. Like when you read problem number 1, what is it that you read that tells you, oh, I have to do a definite integral? In this first pass, your goal is to set up the definite integral. Don't evaluate the definite integral, just set it up. Everybody okay with the instructions? We'll talk in a few minutes.
I'm not sure if I'll tell you right.
The right function.
Between 4 and 2.
Did you set up
Yeah.
the function? Yes.
0, 9.
Well, I forgot to do it. 1,000.
So water is added to the tank at a rate of RT equals blah liters per hour, where T is the number of hours. The tank originally contained 1,000 liters of water. How much water is in the tank at T equals 4?
I did this from 7 to 4. So that's
So would you
where
add that first?
9 hours
Yeah.
passing.
That's a 9?
Mhm.
Okay, I thought it was a 4. Worried me. Okay.
Yeah.
So you're missing the dt.
Yeah, you just told me that.
Yeah.
So,
Okay. So you're saying integrate this and then add 1,000?
Mm-hmm.
Okay. Why?
Because this is a rate function.
Yeah.
So we have to integrate that in and also add the 1,000 because that's what originally was there. We have to account for that because at 4 p.m. you have to take the rate, how much it's increasing because the total amount that you have at the time.
Okay. If you've got your setup for number 1 and you feel good, move on. Don't worry about evaluating right now. Right now it's all about setups.
5. Yeah, 10 over 3 to the power. I mean 2. Yeah, 3. That's what I'm trying to say.
Oh, that's a 9.
Oh, that's a 9.
Just that.
So that's your answer here.
So this from 1 to E?
Yeah.
What is that?
I thought we were supposed to do because it's from T equals 1 to T equals B.
So the problem is you really need to think about this as a whole file.
From 1 to E, right?
It's just to allow
Mine are added. Yeah, saying know what to do with it.
Yeah, I used to just not use it because I didn't know where to put it. I don't know where to put it on my
Yeah, you add it.
Wait a minute. Right. It's not total distances. Oh, we total distance thing we got to add again. We would have to add the 3 too. We would have to add the 3.
Yeah, you can.
Because it, like, if it was total, it would not.
Alright, if I could interrupt all the friends just for a second with question number 1.
Start at 3.
So water's added into the tank at a rate of R of T. T is the number of hours since 7 a.m. Tank originally contained 1,000 liters of water. How much water is in the tank at 4 p.m.? 3 completely different answers. One of these is right, 2 of these are wrong. I'm interested in which ones are wrong and why they're wrong. David, give me one.
The one in the middle.
The one in the middle is wrong. Why? What's a mistake that this person's making?
They actually do it the interval from 0 to 16, but the beginning starts at 7, so that would be 0.
Right. T is being measured in hours since 7 a.m., so don't start at 7. Start at 0. 4 p.m., although it would be the 16th hour, it's 9 hours after 7 a.m. And so now this one's great?
No.
Right now, this one is like this guy over here. So that was part of the problem. What else is wrong with this one? Oh gosh, look at all these people. Andrew, what's wrong with this one?
It's missing the 1,000 liter river.
It's missing the 1,000 in the beginning, and why do you need the 1,000 in the beginning?
Because that's how much water was originally in the container.
Right, what you need to consider is how much water was there originally. So this 1,000 plus the integral from 0 to 9 R of T dt is the right setup. What I was hoping is that you'd see this and you'd be like, oh, this is a fundamental theorem of calculus question. This is how much you had in the beginning, plus how much did you gain in that interval from 0 to 9, and add it all up and we're done and we're good. All right, good. Number 2, car travels with the velocity given by that. At time t equals 1 minute, the car's position is x of 1 equals 3. Determine the displacement of the car from 1 to e. What are we going to do? Displacement from 1 to e. How would we find displacement? And I think there's a poster over here. What a beautiful poster that our friends at East End and North Central and all the other places can't see. Displacement. This is the thing that a lot of folks got wrong in the last units. It's the really big one that says particle motion. Oh, excellent. Now we've leveled the playing field.
One in green.
It's the one in green. Yes, displacement. Aaron, how do you measure displacement?
Wait, oh, you want me to, can I just say the equation?
Yeah.
The definite integral from, well, in this case, 1 to e.
The definite integral from 1 to e.
And then v of t dt.
V of t dt, or in this case, t squared minus 1 over t dt. Now, what about this position at time 1 is 3? We need that, right?
No.
Why not, Paloma?
Because that can only be movement to displacement.
Oh, hold on.
We're finding
This part over
If we're
here
looking for total distance.
is displacement.
Yeah, if we're looking for total distance, then
Yeah.
Adding on the 3 doesn't tell you total distance. Adding on the 3 tells you something else. Displacement is your change in position. If you do 3 plus, what you're finding is not displacement, it's position. Because you'd be saying, here's where I started, plus here's how much I changed by. So don't add the 3. Everybody okay? Alright, number 3, I am interested in your setting it up and you're evaluating it. So see what you can do. Set it up and evaluate it.
You know what, let me know. That's not what whatever.
Wait a minute.
Because of
Are you
rotation.
doing -2 to 2 or are you doing 0 to 4?
Complete from negative 2, and then you.
Oh, yeah, because
Is it
the
rotation
rule
symmetry?
do that. Does that work? Yeah, it does.
Negative cosine.
Sine
Oh,
is
yeah, that's pi over 4.
Yeah.
That's pi over 4.
closer to the
I think you're right. Let's just ask him.
He didn't say we were wrong, he was over here.
Alright, so the setup has to be the integral from -2 to 2
Yeah.
sine pi x over 4 dx. Probably worth a point if it's a free response question.
Will we get points still for f of x dx?
And as long as the function has been defined as f of x, if you just said f of x dx, that would be okay. So Palamon is being very brave and jumping out in traffic and saying that he knows the answer is 0.
I'm playing traffic all the time, so.
I know you play in traffic all the time. Is the answer going to be 0?
Yeah, he's right.
Why?
You sound so mad.
Rotational symmetry.
Why? What is it that you know? Polymon, what is it that led you to believe the answer had to be 0?
Because sine is an odd.
Sine is an odd function, which means that it's going to look something like that.
So it's going to have rotational symmetry, which means as it turns, it basically just cancels out.
Okay. Because you get an odd function, because you've got rotational symmetry, yes, the area is going to be 0, but here's the thing, and I feel like some of you guys are like fading fast on me. My fear is you're going to say every time we integrate the sine function, it's going to be 0.
No.
And that's bad thinking. It's not just the function that you've got to look at, but you also need to look at
Interval.
the limits of integration. You have to be going the exact same amount, right and left, to know for sure that we get cancellation. All right, good. Good luck with number 4. So just you could go through and do the evaluation and you'll see it.
Nah. Close is pi over 2.
Huh? You saying isn't it just
No, not this.
Isn't it just
Average value.
secant over pi over 4?
I've not seen the right setup yet.
Or
Oh, wait, there was one. Oh, no. All right, real quick. The average value formula was you first find the definite integral, and then
Oh, dang it.
you have to divide. So you're looking at the integral of secant of x tangent of x dx from 0 to pi over 4, and I saw a lot of this.
yeah, but divided.
But what that does is it gives you the total, and then you divide by pi over 4 minus 0. And the integral of secant of x times tangent of x?
Secant.
Integral of secant of x times tangent of x. You have to just know this one on sight. Secant of x. So this is secant of x from 0 to pi over 4 divided by pi over 4. So homework this weekend, finish up all 4 of these. I want them evaluated, simplified as much as you possibly can.
So we have to like keep writing?
Yeah, finish them off. And then assignment number 1 in the problem set is just definite integral practice. I'll see you guys later.
Assignment number 91.
Finish those 4,
Number
this
one,
will take
and
long.
I was like,
And then assignment number 91.
I was like, we don't have
I personally